Hello kids. As the Education and Career Division of Sri Lankan Women's Association of Qatar, we thought of starting a series of short videos about some subjects. Not all the subjects, but some subjects according to the availability of the teachers. First one of that series is inorganic compounds formula writing. This is a short video to help for the kids who just started the chemistry as subject. When you talk about formula writing of inorganic chemistry, we have to think about the compounds first. If you talk about compounds, to make a compound, you should have two parts. One is the cation, other one is the anion. Cation is the positively charged ion, anion is the negatively charged ion. Cation usually element, only a single element, but anion may be one atom or polyatom. Like we can say monoatomic or polyatomic. But usually cation, almost all the time it is monoatomic, except one place we have polyatomic cation. We call this one ammonium ion. Okay. In this one, we start with the cation with the monoatomic anions. Okay. When you write a formula, always we write the cation first, then the anion. As an example, think that I have A plus A cation. A is the elemental symbol, plus A, this is the charge. And I have B element with the charge minus B. This is the cation, this is the anion. If I want to make the compound between these two, what we have to do, just take this number, not the charge, just the number here, and this number we have to crisscross. This A go here as the subscript for B, and B goes here as a subscript for A, and then we can write this one as A, B, B, A. As a neutral compound, once you write the formula, number of positive charges should be equal to the number of negative charges. When you do the example, we'll try one or two examples, then you can find out. Once you do the crisscross, automatically it make a neutral compound. Okay. Let's see with some examples. Here I have shown some cations with different charges and also some anions with different charges. If you want to make a compound between sodium and chloride, you know that sodium has one positive charge and chloride has one negative charge. Okay, because both of them has 1 and 1. Usually when you write the formula, we do not write 1. So we don't write any number if it is 1 and 1. So we know that if there is no number, it is 1. Okay. So between sodium and chloride, we just write NaCl. But this one in barium, the charge, it has 2 positive. But here we have only 1 negative. So this number will go here. This number, because always it is crisscross. The number should go to the other element. Okay. So barium doesn't have any number, but chloride have a number because barium has a number here. So BaCl2. Here also the same. Now we'll see whether everything here written are neutral. Sodium 1 plus charge, chloride 1 minus charge. So it is altogether it is 0. Barium plus 2. Chloride minus 1, we have 2 chloride, that means minus 2, then plus 2, minus 2, 0. Here also the same. That means if you crisscross, okay, automatically it become as a neutral the compound. Okay, we'll see this one. Here anion has 2, in here 2 number, there is not 1 like earlier one. So it will be like this, Na2S. Okay, number always go to the other element. Here Here we have a special case. See, barium 2 and the sulfur 2. So usually in the inorganic compound, when you write the formula, we simplify the ratios as much as we can. That means if you have 2 to 2, we do not write 2 to 2. We write simplest ratio like 1 to 1. 3 to 3 means again 1 to 1. 3 to 6, 1 to 2, something like that. Always you have to simplify as much as you can. That means between barium and sulfur, the formula should be BAS. But in here, both of them has numbers, but those we cannot simplify. We just write like this. Okay. So in here, very similar one. Now it has 3. That means Na3N. Here 2 and 3. We have to crisscross like this. But aluminum and nitrogen in here. Aluminum plus 3. Nitride minus 3. That means 3 and 3. It is, we can solve as 1 to 1. So it will be ALN. Now we'll look at the formula writing with polyatomic anions. In this case, in the last row, I wrote already only one we have the polyatomic cation. Okay, so you can see it here. This is the polyatomic cation we can find, but we can find several monoatomic, the polyatomic anions. What are those? I shown some of them. There are a lot of polyatomic anions. Those are very common anions I showed in here. Hydroxide, carbonate, sulfate, nitrate and phosphate. Now we see the rule is the same. There is no difference with the rule. But only thing, if your cation number, I am talking about first 3 cations because those cations only monoatomic cations. If the monoatomic cation has the number of charges more than 1, here 1, here 2, here 3. If you have more than 1, your group, anion group, we have to put a parenthesis. We have to put the bracket. Okay. We'll see. Why we have to put the bracket? Because if you are putting any number, this number should belongs to both elements. Group means you have more than one element. If you just put the number out here, then it belongs to only one element. We cannot put like this. We have to put this number should belongs to both elements. Okay. So, but potassium and hydroxide, no problem. Both of them 1 and 1. So, we can write it like this. But calcium 2, OH minus 1. So, calcium has 1. So, we don't have to write this one. But OH, we should have 2 OH groups. Then we write like this. Here also, here aluminum 3. This 3 should go here. So, it is because again it is more than 1. We have to put the bracket and put the 3. But here 1 to 1. This is okay. In here carbonate 2 but potassium 1. In this case 2 goes here. This time we don't have to put the parenthesis because it is only monoatomic cation. So we just write K2CO3. But in here you can see again 2 to 2. Then you have to simplify. Then it will become 1 to 1. Here 3, here 2. Again the cation number is more than 1. So we have to put the bracket for the anion. But cation we do not put because it is monoatomic cation. Here in this case you can see cation is a polyatomic this time. So your anion has more than one negative charge. So we have to put the parenthesis this time for the cation, not the anion. Something like this. Carbonate sulfate, though those are two groups, the charges are the same. That means formula should be exactly like this. Only difference is instead of carbonate, we just put sulfate. You can see like this. Okay. This is nitrate. Nitrate and hydroxide also has the same -1 charge. That means this column should be really equal to this one. So, only replace is hydroxide with nitrate. Like this. This is different. It has -3. Then these 3 go with the potassium. Now you know the method. Then 2 and because this is 2, we have to put the bracket for phosphate. Here 3 and here 3, then you have to simplify, should be 1 to 1. And here this place, ammonium is plus 1. So you don't have to put the parenthesis for the anion, but anion minus 3, because you have a polyatomic cation, you have to put the bracket in there. It will be like this. Okay, let's see the way of writing a formula if they did not give you the charges of the element. In this case, you have to use a periodic table. This is the periodic table. You know that this is these vertical lines we call groups. The horizontal lines we call the periods. In here, each group has number 1, 2, 3, 4, 5, 6, 7 like that. Okay. We'll see. To write the formula, we find some properties of this periodic table. First one is the electronegativity, other one is electropositivity, both the same opposite thing. Okay, electronegativity. When you go from left to right, electronegativity will increase. From top to bottom, electronegativity will decrease. That means on your left hand side, you can find most electropositive elements. In the right hand side, you can find most electronegative elements. Okay, let's start with the first example. I want to write the formula between carbon and chlorine. Remember, chlorine in the elemental form we call chlorine, but if you write this one as an ion, whatever the ion we call chloride. Okay, and first of all, to write the formula, you have to find out which one is positive, which one is negative. To find out that one, you have to use the property I called electronegativity. Which one is more electronegative between these two? Carbon belongs to the 4th group, chlorine belongs to the 7th group. That means chlorine is more close to the right hand side, carbon is more close to the left hand side. That means chlorine is more electronegative than carbon. So that means carbon is positive, chlorine is negative. Then how many positive? Next step. How many positive? How many negative? Then you have to find out the groups they belongs. Carbon, I said it is 4th group. That means carbon has plus 4. Chlorine belongs to the 7th group. That means Cl minus 1 chloride. Then you have numbers and charges. You have to crisscross. You can write the formula. Second example, between boron and iodine. Again, we have to find out electronegativity. Boron, 3rd group. Iodine, 7th group. That means iodine is more electronegative than boron. So iodine negative, boron positive. Boron 3rd group, so positive 3. Iodine 7th group, that means negative 1. So this is iodide. So again we have to crisscross and write the formula. The third one, between hydrogen and sulfur. Again find the electronegativity. Hydrogen 1st group, sulfur 6th group. That means sulfur should be more electronegative than hydrogen. So hydrogen positive, sulfur negative. So how many? Hydrogen 1st group, so plus 1. Sulfur 6th group, so it is negative 2, it is sulfide. So I have the numbers and charges. Now I have to write the formula. This is the end of the formula writing for inorganic chemistry. If this short video helps you, please comment. Your feedback is really important to continue our journey. Thank you.